Welcome to Advanced Software Architecture. This is the lecture on Design Principles, Part 2. In the previous video lecture, we presented an overview and an introduction to the design process. The goal of this lecture is to get familiar with the first group of design principles in software architecture design. Every principle will be presented with an example, and you will be able to test your understanding of the topic with appropriate quizzes. There are several important design principles that should be used in all phases of software design. The first set of principles that will be covered in this lecture includes information hiding, decomposition, and separation of concerns. Now we start by explaining individual design principles. The first principle is information hiding. Information hiding is the principle of hiding details of an object or function. The primary goal of information hiding is to isolate change and limit its impact. This principle says that all information of a module should be private to the module unless it is required externally. In other words, modules should be specified and designed so that information contained within the module is not accessible to other modules that have no need for such information. Here's an example. This is how information hiding makes it possible to easily make changes to the system. Let's look at a certain software component. This component implements a list as a data structure for storing and retrieving of information. This component hides the information about its internal data structure from other components that use its functionality. This internal private part can be changed. For example, instead of using a list as a data structure, we can replace it by an array. And for this change, there is no need to change the public interface. Also, no component that uses the interface needs to be changed. In this way, information hiding enables changes to be performed locally. This slide is about the open-closed principle. The formal definition is modules should be open for extension and adaptable, while at the same time closed for modification in ways that affect users of the module. First, let's see an example which violates the open-closed principle. This example implements a graphic editor which handles the drawing of different geometric shapes. This design does not follow the open-closed principle because the graphic editor class has to be modified for every new shape that is added. Namely, if we add a new shape, we must also update the graphic editor class with a method that draws this shape. Alright, let's look at an example that does support the open-closed principle. Here, the abstract method draw is used for drawing objects, while the implementation of this method is now placed in the concrete shape objects. Using the open-closed principle, the problem from the first design are now avoided, because the class graphic editor does not need to be changed when a new shape class is added. This slide shows a question, and we're going to test your understanding of the information hiding concept. Let's say that we have a phone that offers several functions, such as placing and disconnecting calls, and creation, removal, and updating of contacts. Software modules can use services offered by the object, but some details of their implementation should be hidden to these modules. If you look at the screen, you see two solutions. Which of these solutions do you think is the correct one? Details about the implementation of the functions that are of no interest to the using modules should be hidden from them. Examples of these are methods for authorization or altering call credits. Now we will look at the principle of decomposition. Trying to deal with something big all at once is normally much harder than dealing with a set of smaller things. A complex system may be divided into simpler pieces called subsystems. Each individual subsystem is smaller and therefore easier to understand. And in the design, in each step, one subsystem is decomposed into smaller subsystems. Benefit of such an approach are that separate components are easier to understand. Subsystems can be replaced or changed without having to replace other parts. Reuse of components is enabled. And from a development perspective, people can specialize on developing particular components without having to know about other components. On this slide, we discuss the principle separation of concerns. A concern is a particular feature or solution mechanism of a software system. For instance, the business logic of a software system is a concern, and so is the security mechanism used in the system. The separation of concerns is a design principle that guides us in separating a computer program into distinct sections, such that each section addresses a separate concern or functionality. The separation of concerns principle manifests itself in various ways in software design. This principle can be recognized in the separation into layers of typical information systems. These systems contain a database layer, a user interface layer, and a business layer. The separation of concerns principle tells us to keep the code for each of these concerns into separate modules or layers. In this particular case, the concerns are separated in the storage and internal representation of a model, the visual representation of the model, and the business logic. Now, changing the interface should not require changing the business logic and vice versa. Separation of concerns through MVC or Model View Controller is also supported by many programming frameworks such as ASP.NET, MVC, Ruby on Rails, and Angular. Let's test your understanding of the separation of concerns principle. Here's a question. We show 4 different designs. Your goal is to choose the best architecture for a class vehicle. For this question, you should keep in mind that issues that are not related to each other should not be handled in one, but in different components. Summary. After this lecture, you should understand the first group of design principles. Also, you should be able to apply these principles in designing and recognize their violation. This is the end of part 2 of the lecture on design principles. Thanks for watching.